Adding and subtracting decimals with many non-zero digits. So we're practice adding and subtracting decimals. Our I can solve problems that involve addition and subtraction of decimals. So make sure you have today's date, your I can, page number, and you should be set. If you haven't done so already, you need to make sure that you put this in your table of contents for this new unit. All right, let's do a little bit of warm up. We're not going to get to the photo part with this, but just something to think about here first. So we have the same problem written three ways. What do you notice? Well, they have the same digits, but what? Man, the only one of these that's correct is this first one here. Why is it correct? Well, it is correct because it has the whole number 5 in the whole number section. Remember that with any number, there's always a decimal that's understood there, and then you can add zeros as you need to subtract. Here, we've just got the 5 lined up where we feel like, which, now that we've worked with decimals, we should know that that is not how we subtract or add these for that matter. So if we subtract this, I'm going to make that into 4. Should be 483, which makes sense. 4 and 83 hundredths. And that makes sense because if you think about it, it's like $5. You pay 17 cents, you're going to have $4.83 back. Here, if you did the same thing, you're talking about what? 33 cents back if you had $5 and you paid 17 cents. Here, you're talking about I had $5, I paid 17 cents, and I only got 12 cents back. Exactly. This is why you have to be careful with where you line everything up. All right, let's dig into some more problems. So we've got a few problems here. Let's go ahead and work through these real quick. Okay. What about this first one here? We got 11 and 3/10 minus 9 and 5/10. This one is a pretty easy one to line up and solve. Because they both have one place value to the right, so you can line it up that way. We have to regroup. And I hope by now that you realize that you don't really have to regroup this. This is all just 10. 10 minus 9 will be 1. But now you could have solved this another way. You could have done something like where you did groups, use like a place value chart, right? You got your decimal in there. And you had one group of 1s, you had one group of 10s. Three here, then you knew you had to take out 5 out of here, so you had to go ahead and take out a group out of there, making that 0, making that 13, and then taking 5 out of there, leaving you with 8, and then coming in near the 1s, taking the 1 group out of there, making 10 here, and getting rid of 9 of those and leaving 1 left. Or you could have even drawn out in the same situation. Drawn out pictures for each of these. And done your regrouping that way and such. I think, drawing out different pictures or using a tens chart to figure out the pieces, or even having those groups of 10 units that where you can physically work with those. Those are fine when you're talking about smaller digits. But here it starts getting a little bit bigger and it gets a little tougher. Not that you still couldn't do it, but it gets a little bit tougher. Do you think that, what about here with this one with C? Yeah, this is something where you're really starting to, you have to represent a very small number, and you really are having to think about its value, because here we're going to the 10,000ths place, which is much smaller, and that just makes things much different, especially when you're talking about something with more numbers, more values, especially in the whole number section. Okay. All right. What about this here? 318 and 8/10 minus the 94 and 63/100. What's the trick here? Well, when you went to solve it, I hope you remembered that you had to put and line up the decimals. When you add or subtract fractions, you must, or add or subtract decimals, you must line up the decimals before you add or subtract. Multiplication and division, it's not important. You worry about the place value later on. And then you add zeros as you need to the right, so that way that you've got all of your columns adjusted to the same. So we subtract here. It's not going to be 3, is it? Nope. We got to regroup. Yep, so I should add 224 and 1700ths. What about this final one? Yeah, and just a little trick. I always try and put my decimal in first. That way I can line up a little bit more efficiently. Those are supposed to be zeros. All right. Then she got an 84 10,000ths. Again, it's all about lining up the decimal. Once you line up the decimal, it is really just straight addition, subtraction, just like you've always done for years now. Let's look at some missing numbers. So in those previous ones, we talked about numbers that were, let me go back there real quick. These were horizontal setup, right? But when I went through and solved them, I did them vertically. I put whatever I was taking out of on top, and then what I was subtracting out of it, I went underneath it. The reason why vertically solving these helps you keep track of those place values and such. It's not that you can't, think about those across that way, but usually they're written that way so that they save space, and then you can solve them out as you need. Let's look at some missing number ones with some vertical though. So, unfortunately, we're not going to be able to work with a partner on this one, but if 1 is my answer here, what am I missing digit-wise? Well, I need zeros in all these places, right? And something that is enough here that when I get done, it makes this into 1. Well, I'm going to need, 6 here. 6 plus 4 is 10. Carry the 1. What am I going to need here? Yep, a 9. Because I need, again, make 10. Carry the 1. Okay, so I have 5 already, so I need, 5 here, which carries the 1, makes that. Go ahead and put my 0 and put my decimal here. So my missing number here was 596 thousandths. What about here? Well, since I've got 9 and something with it, I'm going to need, a 0 here, right? Because since I already have these parts, I need to add something to this that's going to end up at the end adding 1 here. What am I going to need? 5. I'd need a 3 here. Because again, we're making a 0, because we're making 10, carry the 1, 7, and 1 makes 8. So I need, 2 more. And 1 more. Makes back to my 10. Now, all these don't have to be there, but they can help you when you're figuring these out. What about here with this 7/10 minus something gets us this? Well, since it's 7/10, I can put zeros, right? What do I have to subtract out to get the 2 here? No, it's not 2. It should be. I have to regroup from here. This is 10. Now it becomes 9 because I still need to regroup 1 out of it. So I need 8 here, right? 9, to get that down to the 1, I need an 8. What's this have to be? 6, right? Same thing's going to happen on both of these, right? Let's look over just this last one here. There's our decimal. Whatever we're going to subtract out, it's not going to be, or it's going to be pretty large, isn't it? Because we only have 89 10,000ths left over. So if I put all zeros here, and cross all this out, to get that, I need to take out a 1. To get this, I need just another 1, right? Here I'm going to have a 9. Here I'm going to have a 9. A 9 here. There's a decimal in between. And a 6. Doesn't look like that this is what you would end up taking out. But once you start solving through, you can see that you have to, because this is such a small number, you're going to have to take out something pretty large out of this original 70 to make that work. All right, let's talk about that one that we didn't do. If we had this one, if we changed that 7 minus something gave us the 3 and 4,567 10,000ths. What if we changed that instead to 6 and 999 thousandths? It would still work the same, wouldn't it? But at the very end, because we're still going to see we're still going to get the same digits in there at the end. The only difference here is, since this said 7 at the end, it wouldn't have been a 2. It would have been a 3. Or if we do it exactly like it says there, if we had just taken it like this, it would only have been slightly different, wouldn't it? And we could even think of, when I showed this earlier, if I just automatically write this, I could realize that if I took the 1 out of here, it would have to have gotten added in there and made that 3. And that's what the original number should have been. So then you didn't have to do all the regrouping. It's just a flexible strategy. Okay. Could think about the same thing with the second one on the previous part, and think about how that, just using a slightly different digit with larger or with instead of using 7 in this situation, using a 6 and 9,999 10,000ths could help you find the missing number. You'd end up being just one off. You just have to play with that one piece there, and it would just be one different one than the actual number. Same thing kind of here when you think about it. You're only looking at a small piece that goes in with that one. Okay, those are just some flexible number strategies. So pretty easy to see the problems which ones were addition and subtraction, because we didn't really look at the word problems in this one. Some of you may have used the more traditional method like I use. Some of you may have used different drawing out strategies. Kind of depends on what works best for you. Really need to move to that just straight calculating kind of method. And do you use the same thing for all of them? It's something for you to think about. Sometimes doing a flexible thing like I did on that previous one there, where I took and subtracted off the one part and had all 9s already, so I didn't have to regroup. Certainly a different thing to think about with as a strategy that may, for some of you, work quicker. For some of you, it may make it a little trickier. This one's always one to think about here when you're subtracting something like 2 4/10 and you subtract out 1,587 10,000ths. You really got to be careful about lining up those decimals and getting the place values in the correct place. Sometimes even straight drawing out something like what we were doing here earlier can make a big difference. All right, I am way over for today. Thanks for watching.